Okay, so we're looking at changes of state here, and you can see you've got three diagrams of how particles are arranged in solids, in liquids and in gases, and I'm thinking to myself, which of these am I certain about? And the first one I'm certain is that the one at the top is the diagram that shows the particles in a solid. So I'm going to go ahead here and join the top diagram up to where it says solid. And now I'm trying to decide between the next two for liquids or gases. Now I know that particles in solids and liquids are always touching each other, whereas there are big gaps between the particles in gases. So I'm going to go and pick the bottom diagram for liquids. That leaves me with the middle one. That fits with my idea of gases, big gaps between the particles. Okay, so here's a graph that we use to show changes of state, and it's got the characteristic horizontal sections where we know that changes of state are happening. So remember the fact, changes of state, no temperature change. So we've got getting hotter in A and C, changing state in B and in D. Now the question is asking me which part shows melting. So I know it's a change of state. It's either B or D, and B is happening at 0 degrees Celsius. So melting fits with that. I'm going to go ahead and tick box B. And I'm looking at the next question, which is asking me where it's boiling. So I know it's a horizontal section. It's changing state and boiling happens at 100. So we're matching up here and ticking the box D. Okay, this is asking us about the properties of particles. I know that temperature is related to how quickly particles are moving. Now the kinetic energy of particles relates to their movement, and is the answer here. The temperature of the water gets hotter, the particles moving quicker, it's their kinetic energy which is increasing. The next part of this question is asking you to calculate. The equation is here for us. If it wasn't there, it would be on your equation sheet. And I'm looking at the question and I'm identifying where the numbers are that I might need to use. So calculate the thermal energy of 0.25 kilograms of ice at 0. So I know the ice is melting. So there's my mass of ice. And the specific latent heat is the energy required to change the state of the ice. 334,000 joules per kilogram. So I'm going to multiply that by 0.25, which is the mass, just like the equation tells me to. I've written down my working out, and I've calculated that 0.25 times 334,000 is equal to joules, 83,500 joules. Okay, final question, final part of this question here. It's got some words in the box: condenses, evaporates, ionizes, sublimates. I'm discounting the word ionizes because I know that's got nothing to do with changes of state. I know that condensing is, and I know that evaporating is a change of state, but neither of those words can be correct. If we think of solids and liquids and gases, we're being asked what this arrow would be called, which is an unusual word, and you might not be familiar with it. We do know that solids change to liquids when they melt, and liquids change to gases when they boil. And then if I go the other way and cool down, gases condense into liquids, and liquids freeze into solids. The word we need for the top arrow, a solid changing straight into a gas, is sublimation. So the word sublimates fits with this change of state. A sublimating substance goes directly from a solid to a gas.